Good day everyone, my name is Geraldine Mando and in this video I will be discussing three topics: the transpiration, evapotranspiration, and measurements of evapotranspiration. Transpiration is a process by which water leaves the body of a living plant and reaches the atmosphere as water vapor. The water is taken up by the plant root system and escapes through the leaves. Factors affecting transpiration are the following. First is atmospheric vapor pressure, temperature, wind, light intensity, and characteristic of plant. Factors such as atmospheric vapor pressure, temperature, wind, and light intensity is directly proportional to transpiration rates. As these factors increases, the transpiration rates also increases. Now, let's differentiate transpiration from evaporation. Transpiration is essentially confined to daylight hours. It is solely dependent upon growth period of the plant. However, evaporation continues all through day and night, although the rates are different. Now, let's discuss evapotranspiration. Evapotranspiration is simply the sum of water evaporation and transpiration from the surface area to the atmosphere. In hydrology and irrigation practice, it is found that evaporation and transpiration processes can be considered advantageously under one head as evapotranspiration. The term consumptive use is also used to denote this loss by evapotranspiration. Consumptive use is also defined as the sum of water used or need by the crop and volume transpirated in a specific time. It is described as the amount of water needed to meet the water loss through evapotranspiration. It also helps to determine irrigation requirements. If sufficient moisture is always available to completely meet the needs of vegetation, fully covering the area, the resulting evapotranspiration is called potential evapotranspiration. Potential evapotranspiration, or PET, is no longer critically depends on the soil and plant factors, but depends essentially on the climatic factors. The real evapotranspiration occurring in a specific area is called actual evapotranspiration, or AET. There are two stages that are very essential in evapotranspiration. First is the field capacity. It is the maximum quantity of water that a soil can retain against the force of gravity. The second one is the permanent wilting point, moisture content of the soil at which the moisture is no longer available in sufficient quantity to sustain plants. These two stages both depend on the soil characteristic, and the difference between them is the so-called available water. If water supply to the plant is adequate, soil moisture will be at field capacity, and the actual evapotranspiration will be equal to the potential evapotranspiration. However, if the water supply is less than the potential evapotranspiration, the soils dries out and the ratio AET over PET would be less than unity. This is the illustration of the mentioned stages. As we can see, at field capacity, there is an available water for plant growth. Unlike in wilting point, no more water is available. To further illustrate the two stages, here is variation of AET. Generally, in clayey soil, AET over PET is equal to 1.0 for nearly 50% drop in the available moisture. As can be expected, when the soil moisture reaches the permanent wilting point, the actual evapotranspiration reduces to zero. catchment in a given period of time, the hydrologic budget can be written as precipitation minus the surface runoff minus the subsurface outflow and minus the actual evapotranspiration is equal to the change in moisture storage. And now, let's move on to the measurement of evapotranspiration. The measurement of evapotranspiration for a given vegetation type can be carried out in two ways. Lysimeters is a special watertight tank containing a block of soil and set in a field of growing plants. Estimation in lysimeters is based on the amount of water required to maintain constant moisture conditions within the tank. Lysimeters should be buried that the soil is the same level inside and outside the container. There are two types of lysimeters. First is the percolation lysimeters. It is installed to determine simply the vertical soil-water flux or the chemical movement. Next is the weighing lysimeters. It permits the volumetric soil-water content change to be determined by weighing the lysimeters and determining its mass change over time. It also determines the net infiltration from rainfall or irrigation and the amount of evaporation. Another way to measure evapotranspiration is through field plots. It is a special plots where all elements of water budget is in a known interval of time are measured. Evapotranspiration is determined as evapotranspiration is equals to precipitation added by irrigation input subtracted by runoff and subtracted by increase in soil storage groundwater loss.